How do we know that two functions f and g are inverse functions? Let's recall that functions f and g are inverse functions if the composition of f and g is identity, so f of g of x is x for every x in the domain of g, and g of f of x is equal x for every x in the domain of f. So let's look what's happening in this particular example where function f of x equals 3x squared minus 2 and x is greater or equal 0. So this is the domain of the function f, and g of x is square root of x plus 2 over 3 for x is greater or equal negative 2, and this means that this is domain of g. So let's check first that the composition f and g is identity for every x in the domain of g. So suppose that x is greater or equal negative 2. Then we'll look at the composition f of g of x. F of g of x is going to be f of square root of x plus 2 over 3. And to compute that composition, we substitute every x in the formula for f with the square root of x plus 2 over 3. So we'll have 3 times that square root squared minus 2. If we square root will disappear and will be left only with the expression inside the radical. So we'll have 3 times x plus 2 over 3. 3 will now cancel and we'll end up with x plus 2 minus 2, which is x. And that's what we should get. Now let's check the other condition. So let's suppose that x is greater or equal 0. Now, then we are looking for the composition g of f of x. That means I'm looking for the value of function g at 3x squared minus 2. And that is going to be square root of 3x squared minus 2, this goes for x, plus 2 over 3. So we can see that 2 and 2 will cancel out, and we'll end up with the square root of 3x squared over 3. 3 and 3 will reduce, and we'll have the square root of x squared, which is absolute value of x. And because x is greater or equal 0, that absolute value of x is equal x. So again, condition is satisfied. Functions f and g are inverse functions.